Hello everyone. Today let us discuss on the topic principles of preservation. Preservation of food in one form or the other has been practiced in all parts of the world since time immemorial, though scientific methods for it came to be developed only about 100 years back. When preservation techniques were unknown to man, it was the nature which taught him the art of preserving the food. In the case of food grains, nature helped him in reducing their moisture content to a level when they could be stored carefully without much deterioration. In the cold regions, the low temperatures prevailing there helped to prolong the keeping quality of perishable foods. In the hot regions, the sun helped to dry out perishable foods like fruits, vegetables, etc., so that the dried material could be kept longer. In some cases, salting, as in the case of fish and some of the vegetables, and natural fermentation, as in the case of wines, cedars, vinegar, etc., extended to man the availability of a few of his important foods. In the majority of cases, heat or cold was the principal agent employed to preserve many of these foods. Even today, the same principle is employed for preservation of perishable foods. Thus, food preservation can be defined as the science which deals with the methods of prevention of decay or spoilage of food, allowing it to be stored in a fit condition for future use. Now, we'll discuss about the causes of spoilage of fruits and vegetables. Freshly prepared products are highly attractive in appearance and possesses good taste and aroma, but deteriorates rapidly if kept for some time. The food spoilage could be due to one or more of the following reasons. First, fermentation caused by mold, yeast, and bacteria. Second, enzymes present in the product may affect the color and flavor adversely. Third, chemicals present in the pulp juice may react with one another and spoil its taste and aroma. Fourth, air coming in contact with the product may react with the glucosidal material present in it and render the product bitter. Fifth point, traces of metal from the equipment may get into the product and spoil its taste and aroma. Depending on the easiness of spoilage, foods have been categorized into stable or non-perishable foods, semi-perishable foods, and perishable foods. Since most of the fruits and vegetables falls into the perishable group, their spoilage and consequently their preservation becomes almost indispensable. Coming to the principles of preservation. In the preservation of foods by various methods, the following principles are employed. Number 1. Prevention or delay of microbial decomposition. Number A. By keeping out microorganisms. This is known as asepsis. Number B. By hindering the growth and activity of microorganisms. Example, by low temperature and chemicals. Next is by killing the microorganisms. Example, by heat or radiation. The next principle is prevention or delay of self-decomposition of the food. Number A, by destruction or inactivation of enzymes. Example, by blanching. Number B, by prevention or delay of chemical reactions. Example, prevention of oxidation by means of antioxidant. The next principle is prevention of damage by insects, animals, mechanical causes, etc. Various methods of preservation are employed and each has its own merits. The generally used methods are: number 1, asepsis, that means absence of infection. Number 2, preservation by high temperature. Number 3, preservation by low temperature. Number 4, preservation by chemicals. The next method is preservation by fermentation. Number 1, asepsis. Asepsis means preventing the entry of microorganisms, maintaining general cleanliness while picking, grading, packing, and transporting of fruits and vegetables, increases their keeping quality, and the products prepared from them will be of superior quality. Number 2, preservation by high temperature. Coagulation of proteins and inactivation of their metabolic enzymes by the application of heat leads to the destruction of microorganisms present in foods. Heating can also inactivate the enzymes present in the food. Heating food to high temperatures can therefore preserve food. High temperatures used for preservation are usually: number 1, pasteurization temperature, that is heating below 100 degrees Celsius. Number 2, blanching temperature, that is heating about 100 degrees Celsius. And the third is sterilization temperature, that is heating above 100 degrees Celsius. Pasteurization. Pasteurization is the process of heating at boiling temperature or slightly below it for a sufficient length of time to kill the microorganisms which cause spoilage. It is mainly done for fruit juices, ready to serve, that means RTS, and nectar. It does not kill all microorganisms present in the juice, but the survivors are too small in number to cause any spoilage. Acid fruit juices require a lower temperature and less time for pasteurization than the less acid ones. Juices can be pasteurized in 2 ways. Number 1, by heating it at low temperature for a long period, or LTHT. Number 2, by heating at a high temperature for a short time, or HTST. Blanching. Blanching is frequently applied to food prior to freezing, drying, or canning. Usually done in water or steam at a temperature of less than 100 degrees Celsius. The objectives of blanching depend upon the subsequent treatment of food. Blanching prior to freezing or drying is used primarily to inactivate the enzymes besides killing microorganisms to reduce the microbial load in the food. Then the last one, sterilization. Sterilization means the destruction of all viable microorganisms. Heat sterilization is the most effective process of food preservation. It has a severe effect on heat-liable nutrients, particularly vitamins. By these methods, all microorganisms are completely destroyed due to high temperature. The temperature and time necessary for sterilization vary with the type of food. Number 3, preservation by low temperature. Microbial growth and enzyme reactions are retarded in foods stored at low temperature. The lower the temperature, the greater the retardation. Low temperature can be produced by: number 1, cellar storage, that is storing at about 15 degrees Celsius. Number 2, refrigeration or chilling, that is storing at 0 to 5 degrees Celsius. And number 3, freezing, that is storing at -18 to -40 degrees Celsius. Now, cellar storage, that is storing at about 15 degrees Celsius. It is the underground storage mainly seen in villages. It is usually not much below that of the outside air and is seldom lower than 15 degrees Celsius. It is not enough to prevent the action of many spoilage organisms and plant enzymes. But decomposition, however, slowed down considerably. Root crops, potatoes, apples, and similar foods can be stored for limited period during the winter months. Next, refrigeration or chilling storage, that is storing at 0 to 5 degrees Celsius. Chilling temperatures are obtained and maintained by means of ice or mechanical refrigerations. Fruits, vegetables, and their products can be stored for a few days to many weeks when kept at this temperature. Number 3, freezing, that is storing at -18 to -40 degrees Celsius. Freezing method is the most harmless method of food preservation. Microbial growth is inhibited and the rate of chemical reaction is slowed down at a low temperature. At temperatures below the freezing point of water, growth of microorganisms and enzyme activity are reduced to a minimum. Most perishable foods can be preserved for several months if the temperature is brought down quickly and the food kept at these temperatures. The best way of preserving pure fruit juice is by freezing. Properly frozen juice retains its freshness, color, and aroma for a long time. Number 4, preservation by chemicals. According to the British Food and Drug Act of 1928, a chemical preservative is any substance which is capable of inhibiting, retarding, or arresting the process of fermentation, acidification, or other decomposition of food, but does not include common salt, that is sodium chloride, saltpeter, that is sodium or potassium nitrate, sugar, acetic acid or vinegar, alcohol or potable spirits, spices, essential oil, or any other substance added to the food by the process of curing known as smoking. Pasteurized squashes, cordials, and crushes have a cooked flavor. After the container is opened, they ferment and spoil within a short period, particularly in a tropical climate. To avoid this, it is necessary to use chemical preservatives. Chemically preserved squashes and crushes can be kept for a fairly long time even after opening the seal of the bottle. However, it is essential that the use of chemical is properly controlled, as their indiscriminate use is likely to be harmful. Thus, there are two kinds of preservatives. Number 1, Class 1 preservatives. This includes common salt, sugar, dextrose, spices, vinegar, and alcohol, etc. And number 2, Class 2 preservatives or the chemical preservatives. Among the Class 2 preservatives, only 2 chemical preservatives are permitted in many countries including India. They are sulfur dioxide and benzoic acid. First, the sulfur dioxide. Sulfur dioxide is widely used throughout the world in the preservation of juice, pulp, nectar, squash, crush, cordial, and other products. It has good preserving action against bacteria and molds. It also retards the development of yeast in juice, but cannot arrest their multiplication once their number has reached a high value. It also inhibits enzymes, and in addition, it acts as an antioxidant and bleaching agent. These properties help in the retardation of ascorbic acid, keratin, and other oxidizable compounds. It also retards the development of non-enzymatic browning or discoloration, that is, after killing the enzyme of the product. It is generally used in the form of its salt, such as sulfide, bisulfide, and metabisulfide. According to FPO, the maximum amount of sulfur dioxide allowed in fruit juice is 700 ppm, in squash, crush, and cordials 350 ppm, and in RTS and nectar 100 ppm. The next chemical is benzoic acid. It is partially soluble in water, hence its salt sodium benzoate is used. 1 part of sodium benzoate is soluble in 1.8 parts of water at ordinary temperature, whereas only 0.34 part of benzoic acid is soluble in 100 parts of water. Sodium benzoate is thus nearly 170 times as soluble as benzoic acid. Pure sodium benzoate is tasteless and odorless. Benzoic acid is more effective against yeast than against molds. It does not stop lactic acid and acetic acid fermentation. According to FPO, its permitted level in RTS and nectar is 100 ppm, and in squash, crush, and cordial is 600 ppm. In the long run, benzoic acid may darken the product. It is therefore mostly used in colored products of tomato, jamun, pomegranate, plum, watermelon, strawberry, colored grapes, etc. The next method is preservation by fermentation. Decomposition of carbohydrates by microorganisms or enzymes is called fermentation. This is one of the oldest methods of preservation. By this method, foods are preserved by the alcohol or organic acid formed by microbial action. The keeping quality of alcohol beverages, vinegars, and fermented pickles depends upon the presence of alcohol, acetic acid, and lactic acid respectively. Care should be taken to seal the fermented product from air to avoid further unwanted or secondary fermentation. Wines, beers, vinegar, fermented drinks, fermented pickles, etc. are prepared by this process. 14% alcohol acts as a preservative in wine because yeast, etc. cannot grow at that concentration. About 2% acetic acid prevents spoilage in many products. Now coming to the conclusion. Fruits and vegetables are grouped under protective foods, being a good source of vitamins and minerals. Fruits and vegetables are seasonal and highly perishable. They begin to deteriorate shortly after harvest. Biochemical and microbial spoilage are likely to occur. So, to enhance its shelf-life, different preservation techniques are required. When preservation techniques were unknown, it was nature who taught him the method of preservation. The general principles involved for preservation of foods are: number 1, prevention or delay of microbial decomposition; number 2, prevention or delay of self-decomposition of the food; number 3, prevention of damage by insects, animals, and mechanical causes. Using these principles, different methods are employed for preservation of different products of fruits and vegetables.